Hey there, welcome to another Dylan Does tutorial. I want to show you a little bit about simple linear regression in R. So to do that, we'll actually use this small little case. A manufacturer has developed a quantitative index for the sweetness of orange juice. And what they want to do is see if there's a relationship between the sweetness index and a chemical measure such as the amount of water-soluble pectin in the orange juice. So we'll do a couple things. First, we'll import some data and then look at the summary of the data and do an analysis on the variance of the data. From that, we'll just create a plot and be able to predict certain values given an input. So let's get started. We'll first read in this index, this table from a file that we choose in my directory. And we're going to make this so we can have headers using the header equal true. If we run this, using Control Enter, get this pop up, and should be at the bottom. There we go, orange juice. I'm going to pause this because this happened just 2 seconds. Alright, so I'm back up and running, and we have our orange juice table. And if you look at it, we have a sweet index and a pectin index, or measurement. So now what we want to do is we just want to do a summary of this data. And we'll do this by using this reg function. Sorry, not reg. We want to do a regression using a linear model of sweet index on pectin on sweet index using the data orange juice, and we'll select this and run it. Now so as you can see here, R ran something and it's waiting for a console. A lot of the times it will look like it did nothing, but in reality it did. So let's look at our data. So as you can see, pectin, its beta 1 coefficient is negative 0.002, has a standard error that is confident at the 90% or no, the 95% confidence interval. So this is pretty good. This is a pretty good estimate that for every increase in pectin, the sweet index will decrease by 2 thousandths. And we'll just do a quick ANOVA analysis of the variance. Looking at the residual data. And this is also confident too. Here's the degrees of freedom, the sum of squares, the mean of the squares, and the F value. And really that's what we're looking for. We just want it to be statistically significant. Alright, so moving on, what we want to do is create a trend line and analyze what the effect is, or what the predicted effect is of pectin on sweet index, so we can measure for future batches what a certain amount of pectin would correlate to in a sweet index. So to do this, use this abline function on reg. Oh, sorry, there has not been a new plot. So let's plot this first. We will plot sweet index and pectin from this data orange juice, and we're going to put some limits on. We're going to make the y limit 4 and 6. This is just because There's no data less than 4. There's no data greater than 6. And we'll make the X limit. Take a look at it. I don't see any data less than 200. We got one that's 400. So I guess 400 is not bad. We'll close that out. Run this line. Unexpected comma. Where is it? Got a comma here. Got a comma after orange juice. That's why. Need to put it as a C, an X limit C. There we go. So now we have this plot of what our data looks like. And as you can see, if you look way out towards parts or pectin and parts per million, if you get about 380, it is around less than, or it is around 5.2. There might be some trend, but let's take a look. There you go. There it is, a trend, a downward sloping trend. Now, we can compare this with the mean by doing a similar ab line. Just let's get the mean of reg. Oops. We want to get it on the sweet index. I don't know if that's going to run. I might have to call the object. Yep. Alright, we'll just do OJuice with a $. And the mean is 5.65. So we'll do another ab line at a height of 5.65. 833. And we'll run this, and we'll actually do another mean ab line, and there we go. So there's our mean, there's our predicted score for any given value, and now we want to find out what a value would be if we predict it. So we're going to predict a value on reg, and we're going to create a new data frame to do this. So what if pectin is, say, 300? Well, when we run this, we will get a corresponding estimate. So if we have 300 pectin parts per million, we can expect our sweet index to be 5.55 with a confidence of 90% or 95%. So that's how you just do a simple linear regression in R, and thanks for watching.